Okay, just imagine this for a second. You've made it. You've journeyed millions of miles, explored the red canyons and vast plains of a whole new world. You've literally made history. But now comes the single biggest challenge of the entire mission. How do you get home? So let's dive into how we're going to solve the ultimate interplanetary logistics problem.
Right? It's a question that sounds so simple, but it is one of the toughest nuts to crack in all of space exploration. I mean, you can't just call an Uber. The answer isn't about building a bigger, more powerful rocket on Earth. It's about being really, really clever on Mars. And it all starts with a fundamental law of physics that, honestly, can be a real pain.
Ah, yes, the tyranny of the rocket equation. It's a beast. For every single kilogram you want to send to Mars and back, you need fuel. But of course, that fuel has weight. So you need more fuel just to lift that fuel. It spirals out of control. Trying to bring a fully fueled return rocket all the way from Earth would mean your launch vehicle would have to be astronomically huge and expensive. It's basically a non-starter. So how do we break this vicious cycle?
Well, just like in The Little Prince, the solution isn't to carry more water into the desert, but to find a hidden well. And on Mars, in that vast red desert, there is a well. It's not a well of water, necessarily, but a well of resources. We just have to learn how to live off the land.
And that brings us to this absolutely beautiful acronym, ISRU, In Situ Resource Utilization. It's the whole cornerstone of modern plans for exploring Mars. Instead of packing everything for a round trip, food, water, air, and fuel, what if you just packed for a one-way trip and then made what you need for the journey home right there on Mars? It is a total game changer. So where is this Martian well? What resources does the red planet actually have to offer? Well, it turns out you just have to look up. The most abundant, easiest to get to resource is the Martian air itself. And take a look at this. The atmosphere on Mars is over 95% carbon dioxide. Now for us, that's completely unbreathable. But for an engineer, that's a gold mine. That CO2 is the raw ingredient for pretty much everything we need, both the air we need to breathe and the fuel we need to burn to get home. So, the very first step is to prove that we can actually tap into this resource. And here's the best part. This isn't science fiction. It is happening right now, on the surface of Mars, with a little instrument that is already making history. Meet MOXIE, the Mars Oxygen ISRU experiment. It's a little gold box, about the size of a car battery, riding along on the Perseverance rover. And that tree analogy, it's perfect. It literally breathes in the toxic Martian air and breathes out pure, life-giving oxygen. So, how does this little magic box work? Well, it's a pretty straightforward three-step process. First, MOXIE sucks in that Martian air. Then, it heats it way up and uses electrolysis to literally rip the carbon dioxide molecules apart. Finally, it breathes out pure oxygen with a little carbon monoxide left over. And the most incredible part? It works. MOXIE has already done this successfully multiple times on Mars, proving the concept is solid. Okay, so we've got oxygen. That's fantastic for breathing, and it's half of what we need for a rocket engine. But oxygen is an oxidizer. It needs a fuel to burn with it. So how do we make rocket fuel? For that, we turn to a brilliant bit of chemistry that's been around since the 19th century. Let's look at the recipe for Martian rocket fuel. It's surprisingly simple. You only need to bring one key ingredient from Earth, a small tank of hydrogen, which, is the lightest element in the universe. You combine that with all the CO2 you can suck up for free from the Martian air, and you mix them together in something called a Savitier reactor. Now, this process is just ingenious. In the reactor, the hydrogen and CO2 react and create two things we want: methane, which is our rocket fuel, and good old H2O, water. But here's where it gets really smart. You then take that water you just made and split it apart using electrolysis. That gives you oxygen for your rocket engine, and, crucially, it gives you back some of your hydrogen. You can then just feed that hydrogen right back into the reactor to make even more fuel. It's this beautifully efficient, self-sustaining loop. Okay, so we have a process that works. But what does this really mean in practical terms? Why go to all this trouble? Well, this right here is where the tyranny of the rocket equation becomes the triumph of ISRU. 20-1. Let that number sink in for a second. This is everything. For every 1 kilogram of hydrogen you have to haul all the way from Earth to Mars, you can generate 20 kilograms of methane and oxygen rocket propellant right there on the surface. That is a 20-1 leverage. It completely changes the game for how you plan a human mission to Mars. So let's put all these pieces together. What does this whole system actually look like in practice? Well,
It looks like the most remote gas station in the entire solar system.
And this image just illustrates the whole idea perfectly. A spacecraft lands on Mars, its return fuel tanks nearly empty. Then, for the next year or so, while the astronauts are out exploring, an automated plant just works away day and night, sucking in the Martian atmosphere and using that Sabatier process to slowly fill the tanks. And when it's time to go home, you have a fully fueled rocket ready to go.
And the innovation doesn't even stop with methane. Scientists are looking at even more direct, almost brute force approaches. I mean, what if you just brought along a bunch of powdered metal, like magnesium, and literally burned it using the CO2 in the atmosphere as your oxidizer? It's a much simpler chemical reaction, and it could be perfect for smaller vehicles or even as a backup system. So, after all of this incredible chemistry and mind-bending engineering, what's the bottom line? Why is living off the land such a truly revolutionary idea? Because ISRU is the technology that truly unlocks the solar system for us. It's what moves us from just being visitors to other worlds to actually being able to live and work there for the long haul. This is how we take that next great leap. When you boil it all down, ISRU makes going to Mars more affordable by slashing the launch mass from Earth. It makes it safer by giving astronauts a way to produce their own air and fuel locally. It is, without a doubt, the single most important key to our future as a multiplanetary species.
And that just leaves us with one last really fascinating thought to ponder. The very same chemical engineering that could power our journey to the stars is designed to do one thing: take excess carbon dioxide, a pretty big problem here on Earth, and turn it into a valuable fuel. Who knows? The technology we're developing to get home from Mars might just end up helping us save our own planet.